So, welcome everyone. I'm excited to be here. Thanks, Santiago, for joining me. So this is the first day of our DataTalks.Club summer marathon, so which is a conference, but not really a conference. It's more like a bunch of meetups. So for 2 weeks, every day, we will have a small talk, like a small meetup. And today is the first day. So the first week, we'll talk about different topics in career, in data, and the next week, we'll talk about machine learning in production. So this is the lineup we have for this week. And so first, today we are talking with Santiago about transitioning from software engineering to machine learning. Then tomorrow we'll talk with Daliana about getting a promotion in data science. So the talk will be the next level of your data science career. Then we'll talk about data engineering and how data scientists can build their own data pipelines. On Thursday, we'll talk about two different roles, big data engineer and data scientist, and what are the difference between them. And we will end this week with a talk about building a machine learning startup with Elena. And if you haven't registered for our conference, there is a link in description. You can just go there and you can sign up for the other days. And then finally, subscribe to our YouTube channel to stay up to date with all our events and join our Slack to talk about different data topics. During today's interview with Santiago, you can ask any question you want. And for that, please use a pinned link in the description in the live chat. So just click on this link and ask any question you want. And yes, Santiago was kind enough to provide 10 copies of his course. And here are the winners of his course. I will announce this later, but thanks a lot for taking part and congratulations on winning this course. And last but not least, this event is supported by many of our partners, by 8 of them. Thanks a lot for your support, for helping us with organizing this event, for promoting it. And please go to our conference website and check them out. All of them are doing really cool stuff. And that's all for the introduction. And now I should stop sharing my screen. And yeah, Santiago, are you ready?
I am ready.
Okay, so let's start.
Absolutely.
Yes, so today we'll talk about career transitioning from software engineering to machine learning. And we have a special guest today, Santiago. So Santiago is a director of computer vision solutions at Levitas. And there he leads a small team of software engineers and machine learning engineers. Santiago is a computer scientist who focuses on applied machine learning. And you probably know Santiago from his Twitter. On Twitter, every day he shares a lot of practical things about machine learning. Thanks, Santiago, for joining us today. Welcome.
Thank you for inviting me.
Yeah. Before we go into our main topic of moving from software engineering to machine learning, maybe we can start with your background. Can you tell us about your career journey so far?
Absolutely. So I started as a software developer. I went to college, got a computer science degree, and I started building software. And I think it was 2015 when I decided to go for a master's in computer science. And back then I had no idea about machine learning. I didn't have any interest. It was during the master's that I decided to focus more on machine learning. And I know you've been using the word transitioning from software engineering to machine learning. I like more the word adding to my skill set, the machine learning skills, because I think if you're a software engineer, you are already providing a lot of value. By incorporating machine learning, now what you're doing is augmenting the impact that you can have on the industry. So that's basically a short description of how I went about it. It was through my master's. I started working more on machine learning, started getting more responsibilities on that area, up to today, where I'm mostly focused on that area. Yeah.
And I'm following you on Twitter, and I noticed that recently you posted a picture from a local, from your youth, I think from Cuba. Like it was a picture of a newspaper. Yeah. So you're from Cuba originally, right?
I am from Cuba. Yeah, I came here to United States back in 2009, May 1st of 2009. So I've been here for 12 years now. Yeah.
Okay. Yeah. So you got you did your bachelor's in there,
So I
right?
did, yeah, I did my bachelor's in Cuba. It was computer science, and then I went through my master's here in the States. It was Georgia Tech, their online master's program, which is fantastic. Yeah.
Yeah, I think I saw it also from. I think I know, like because you post so much on Twitter, so I already
Yeah.
know this bit as well. And I think in this picture that you shared from Cuba, it was two guys, like you and your friend. You
Yep.
were staring at the computer, and your comment was that you didn't have any internet connection back then, so you just.
Yeah, back then, I think the first time we saw internet during my college degree or my college stint, I think it was 2000, maybe 2001. That was the first time that we got access to internet. So back then it was about having a couple of books, and that was it. And the knowledge that we shared was mouth to mouth. That you had to talk to people if you wanted to know something that you didn't know. So that it was very different to the way it is today, that you can find so much information online. Literally anything that you want to know is going to be online in some form. So yeah, definitely very different.
Yeah, I see why you love books.
Oh
Maybe it's
yeah,
coming from
that's exactly why I love books. Yeah, for sure.
Yeah. So you mentioned that you don't like to think from like when I say transitioning from software engineering to machine learning. You said that you don't like this word transitioning because you didn't really transition. You just added machine learning to your skill set as a software engineer, right? So do you think that software engineers are already qualified for doing machine learning?
I do. I actually, so this is what I think, right? One of the hardest skills for you to get and start providing value in the machine learning field is precisely coding, is your ability to develop solutions, right? To your ability to make the computer do what you want. That's one of the hardest skills that you can build. So if you're a software engineer, if you already have that skill, you're definitely halfway home. You definitely have what's needed to be successful in a machine learning field. It's interesting that most people are afraid of the math, but what I've seen is that most people that don't continue, that are left behind, it's not because they lack math skills, it's because they lack coding skills. So yeah, if you were to ask who's better positioned to be successful, 9 out of 10 times, I'm going to pick the person who already knows how to develop software and provide value through software, for sure. Yeah.
So software engineers are basically already qualified for this work.
Oh yeah, absolutely.
They just need to convince themselves that math is not the most important.
It's not that
thing.
Scary. It's not that scary. Yeah, math, you're going to need math. And yeah, the deeper you go, math is going to become more important. But it's not that scary. I promise you, if you have the skills to build software, you can have a huge impact just with those skills and a little bit more math that you're going to incorporate as you go. Yeah, for sure.
Yes, but how do we, as software engineers, how do we convince ourselves that math is not scary? Because I remember when I was studying machine learning, I remember that like all these formulas, like especially when you talk about more difficult concepts like support vector machines, like you have these crazy formulas, like crazy, or maybe somebody who studies math will disagree that it's crazy, like they would say, okay, it's just first level, like first grade calculus, whatever. But when I look at this, it's scary. So how do I convince myself that it's not scary, that I shouldn't worry about this thing?
Yeah, I think it's a great question. So number one, we have to think about the way machine learning content has been, or who's sharing that machine learning content mostly. And if you think about it, it's mostly coming from academia, right? It's papers, it's the people who invented those formulas are writing books and are recording YouTube videos. And obviously, it's really hard when you get to a blog post and you cannot get past the second paragraph because there is a huge formula right there at the beginning, right? That is, I have the sort of like the hope that that's going to get better over time. I'm working on it. A bunch of people are working on it, trying to share the other side of machine learning. which is a very different approach to understand and to learn how to make progress in the field. Like instead of starting with how the thing is built, it's you start with what can you use and how you can use this concept to solve that problem. So it's a very different approach. Think about when you go to school and they teach you a bunch of physics and chemistry and math, just because it's just like sort of like a general foundation that maybe you're going to need later, maybe you will not need later. That has pros. It also bores a lot of people. A lot of people start there and they don't know where they're going. But they go through so much math content that they don't know, why is this going to be useful? Another approach is to start with problems. Another approach is for you to look at a problem and say, what do I need in order to solve that problem? And yes, I know that a lot of people say, well, you cannot use something effectively unless you know how that thing is working. And I understand there is just a spectrum, right? You can know very, very low level details of how it works internally, or you might know just the necessary things that it does in order to solve the problem. Like not everyone that's sorting a list right now knows exactly how the algorithm works. I know extremely effective Python programmers that don't even know that the sorting behind Python is called team sort. They have no idea. They can still sort lists, right? Now, the other person will tell you, but if there is something wrong with sort, they will not. Sure, when that happens, they can go and dive deeper and get the knowledge they need to understand how team sort works. But I don't think everyone needs to start from the nuts and bolts of the content. I think you could also start from the beginning, trying to make an impact. That's what things like AutoML is doing, right? They're providing tools that you can use without the need of having somebody that knows the calculus that goes behind the scenes. I think it's a different approach, and it's something that you're going to see more and more as time goes on, for sure.
Mm-hmm. And also, to add to your analogy of knowing sorting, how many times it happens that your sorting algorithm doesn't work? I don't know, has it ever happened to you that sorting didn't work?
Never.
Yeah, then
So and by the way, I'm not talking about not understanding sorting at all is a good idea. I'm saying it's a spectrum, right? So how much you understand about sorting will definitely help you. If you know more, might be helpful for you. That's okay, but you cannot limit people just because they don't know is team sort. You should not limit them on what they can accomplish.
You shouldn't guard them from the computer and saying,
absolutely,
no, don't touch the keyboard until you can show me like all the properties of the team sort, right?
Yep. Like, for example, I've been posting a lot of content on Twitter, and usually the approach that I take is how much jargon I can remove from this content so more people understand what's happening, right? So if I'm going to talk about, let's say, I just posted a tweet last week about ensemble learning. And when you read the topic online, there is so much jargon and things that you need to know in order to even understand why an ensemble works. So my challenge is, how do I remove all of that and still make it accessible to more people that they might not be ready to build an ensemble, but they will understand it's a tool that they can pick up. They understand that it's valuable. They understand the situations where to use it. And I think more and more, you're going to see more and more of that content coming because more people are going to want to use machine learning and apply it to their use cases. So I think that's a good thing.
Yeah. And yeah, it's a good thing that you're doing on Twitter because you have this ability to put complex things in simple terms. And I agree with everything you say. So to me, it's like you're just sometimes I feel like you can read my mind and just tweet it out. This is really great because I agree with almost everything you say. So this is cool. Thanks for doing this. And how do you actually go about this removing jargon? Because I think even though it's not super related to the topic today, I think it's interesting like how it is possible to like these are complex terms, complex things like ensemble learning. So how do you make it accessible for people?
Yeah, I think this goes more into writing and what would I do, but just as a sort of like a way to answer the question is, so I write down sort of like an outline of what I want to explain, and then I use my wife as my guinea pig. Can you understand what's happening here, right? And she usually points out terms that to me are very clear, but have no meaning to her, right? So that helps me a lot. And usually also asking the question, can a 6-year-old understand what I'm trying to put here? And you know what? Sometimes you can do it, but it's always about trying a little bit harder and sort of like getting the feedback from the people who read that thread, who read that content, that what questions do they ask? Does it help them? And sort of like incorporating that feedback in your next thread. So it's usually a battle, and it's usually also a spectrum of how easy can you make something before it doesn't make sense anymore, right? Like if you try to make it so easier, then you're not helping anyone. But if you make it too complex, then you're, leaving out everyone else. So yeah, it's usually a battle, but it's a nice battle to fight. It's something that I enjoy for sure.
Yeah, thanks. So speaking of Twitter, so just before this conversation today, I opened Twitter, just wanted to check what you've been up to. Mm-hmm. And I noticed this nice thread, which is very on topic for today's conversation, which is about 7 lessons I learned about starting a career in machine learning. Mm-hmm. Do you remember what are these 7 lessons?
I can have it in front of me right now. I remember some of them. Yeah, I think I have it right here.
So yeah, maybe you can walk us through a bit these lessons, because I think these are very useful for software engineers who want to transition today.
Yeah, absolutely. So first of all, the context, this is trying to do a little bit of a retrospective myself and how did I get into the field, the things that I learned, and also about this year of it's been a year now that I've focused a lot on helping people get into the field, right? So just looking at the questions they ask, looking at the problems they've had, what can we learn from that, right? So the first lesson is it applies to a bunch of different things, not only machine learning, is that most people really enjoy the idea of starting something new. Unfortunately, they fail to take the first step, right? It's like, you decide that you want to make a change in your life, you want to go to the gym, and you start buying supplements and you start buying shorts and shoes, and that process really is exciting, but you never show up, you never go to the gym, right? So the sort of like the lesson here is don't be like that person, right? Don't prepare. You don't need that much preparation, right? You just need to take the first step. You just need to do something today that gets you a little bit closer to that job. I think that's the first lesson.
It's like buying a course about machine learning and getting excited. Hey, now I will finish this course. This is how much I will know. And then you come across the second one. But this is even cooler. Let's have this one as well. And then there is a third one, and there is a cool free course.
Yep.
And then there is a book somebody recommends you, and you want to get all of them, right? But at the end, you just collect resources and you don't do anything.
That is exactly right. It is, most people spend so much time trying to find the best course, trying to find the best tutorial, the best video. And there is no best tutorial, there is no best course. It's whatever you have in your bookmarks is plenty enough. So go through that and then decide what's going to be better for you. But just stop preparing. You just need to take the first step. So yeah, so the second lesson, it's basically learning is a marathon, not a sprint, right? I get a lot of questions of people asking me, hey, can I become an expert in a few weeks or in a year or in a month? Or the reality is that machine learning, no different than any other field, it's a lifelong journey, right? So if what you're trying, machine learning has been selected for the last few years as the sexiest field to be in and stuff like that. And then people want to get into the field because they think it's a shortcut to success, or they think they're going to be making a lot of money, or right? That mentality I don't see helping, right? So instead, if you're coming in, understand what you're setting yourself up to, right? Understand that this is a lifelong journey. It's a field that moves really, really fast, and you're gonna have to keep up, right? And you're gonna have to dedicate a lot of time to become good at it. So it's just setting the right expectations for you to start in the field. Yeah.
So there is
So
no
that's the
magic
second
bullet,
one.
right?
Yeah. There is no magic, and there is no shortcuts. It is hard. It's super rewarding. It's easy to start, but it's gonna be a lifelong effort for sure. Yeah. So lesson number 3, it's basically a proverb that I used it there, which is, if you want to go quickly, go alone. If you want to go far, go together. And here the idea is that the people that I've seen that have made most progress are always part of a community, are always part of a group. It's really hard to make progress when you are alone, right? So find like-minded people that want to take this journey with you, right? There is a huge online community, online machine learning community. Just try to be there with them, right? Try to join, try to find other people that want to bounce ideas off of you, and vice versa. Try to find people that are taking the same classes as you are, and that will boost your odds significantly, right? You're gonna make a ton of progress just because of that. In my case, my teaching is a way for me, or is one of the most powerful ways I have to learn, right? So I come here, and I'm not only writing about stuff that I know. A bunch of stuff that I've gone to Twitter and talked about on Twitter is stuff that I don't know what I'm talking about, right? I just read about that, and the process of writing about it is the way that I learn, right? And that's thanks to the community that's going to give me feedback, that's going to challenge my ideas. That's extremely important if you're trying to get into the field, for sure. Yep.
Okay.
So lesson number 4, if you finish a course and the only thing you have to show for it is inside your head, you probably wasted your time, right? And here the idea is you have to do stuff, not only just consume information. You have to produce something, right? So if you're watching a tutorial, do something with it. If you're reading a book, stop after the first chapter and think, how can I apply what I learned? If you don't do that, unfortunately, you are going to forget. Even if the doing means going to Twitter and talking about it, that is doing. That's the act of taking that knowledge and applying it somehow. That is extremely, extremely important, right? If you're not doing stuff with the knowledge that you're acquiring, the knowledge is going to, it's not going to stay for long, for sure. Yeah, I can.
Yeah, so you were saying that, so you were writing about these ensemble methods, and you would test what you wrote on your wife. So I guess this is a great example of how you can actually, when you learn something, when you study something, try to teach the other, or some other person about this. Talk to your wife or somebody. And if they understand, then this is a lot better than just reading, closing your book, and not doing anything with this information.
Yeah, one thing that I've been doing is I have now that Twitter supports Twitter Spaces. So basically, you get the microphone and a bunch of people join you, and you can get to talk to a bunch of people. So I've done Twitter Spaces to talk about a topic that I just learned, just so I can explain it to someone else. And a bunch of people join, and they ask me questions, and they test what I learned, right? So I have to get prepared to do that, and that preparation forces me to solidify that learning, to understand a little bit better. So that's extremely powerful.
Is it a regular thing you do on these Twitter Spaces?
What's that?
Is it a regular thing that you do? Do you do this
So
often?
I've been doing it very regularly. So usually per week I do it once. Sometimes I join somebody else's space and I talk about the stuff that I'm learning on or whatever. I do my own, or sometimes I do my own space and talk about a specific topic.
Do you have like a specific time frame when you do this,
or
you just when you feel like you just tweet it out and then?
It's when I was doing one every weekend, but then after that is whenever I have the time to join, I try to do it. Yeah.
Okay. So people
So
have to
lesson.
follow you, right? Sorry.
Yep.
To follow you to
Yep.
know when you're doing this.
Yeah, you have to stay tuned. Yeah, for sure.
Sorry.
Yeah, so the fifth lesson on that thread is people think about math every time machine learning comes up. And then I say, I think they're missing the point, right? So I do not believe machine learning is more math than coding. I do believe, like I look back at my master's and a lot of people were taking the machine learning class, and most of us were really scared about the math because everyone is, unless you have a math background, everyone is scared about the math. It turns out that by the end of the class, the people who didn't make it because of their coding skills. They were not able to translate the ideas into code. They failed to do that. That was really hard. That was the hardest part of the class. So when I work every day, that I get to meet people, I get to talk to other teammates. The ones that struggle the most are the ones that are not capable of building solutions. Yes, analysis is super important. Yes, I do believe analysis is better than code, especially when you're studying. Your ability to analyze a problem and understand what needs to happen, it's crucial. But at some point, you have to deliver value, and that is through code. So I think math is extremely important, but it shouldn't be the thing that scares you out of the field. It's just a thing that you're going to have to learn, but it's not that scary, I promise you. So that's the fifth
We
lesson.
already have a bunch of questions about improving coding, but I think we should come back to that a bit later when we finish this lesson.
Two more lessons to go. I already mentioned this one here, but coding is secondary. Your ability to analyze a problem is the most important skill you can build. And this seems a little bit counter narrative to what we just said.
Yes.
Right. But it's so think about it this way. When you're studying, right, the skill that I want you to build is the ability to read a problem and understand, analyze how to solve that. That's the skill that I want you to build. This is not to say that overall, as an engineer, coding is secondary. This is as you study now. Assuming that you already have knowledge about how to code, I want you to put that aside. I don't want you to focus on grab that code from Stack Overflow or I don't want you to focus on that. I want you to focus on understanding the problem. That's a muscle, and I want you to exercise that specific muscle. After you know what needs to be done, now you can focus on the coding part. Now you can grab the code from Stack Overflow, from the book, or from the tutorial that you're reading. First, understand the problems, understand different possible solutions, how to pick a model, how to do the error analysis, all of that. I think that's very, very important to start in a machine learning career.
How can somebody actually pick up the skill? Is it just work, or there is
I think it starts by you putting the code aside and not focusing on that. If you start with a problem, most of us, this is the way I've built my entire career. I find a problem and then I go online and find somebody else that solved it and see how they solved it, right? Some people think that that's cheating. Well, that's my entire career. If somebody else did it, I'm going to use what that person did for sure, right? So it's putting that aside and forcing myself to think through the possible solutions, right? It's more about consuming the content and trying to apply those ideas and less about finding a library that does the work or finding somebody else that coded it, right? Just forcing myself to think through what are the ideas? Why is this solution the one that I should pick, right? It's trying to just dig a little bit deeper in the books, dig a little bit deeper in the math at the beginning, just so I can build that foundation. And finally, lesson number 7, this is a quote. It says, you have to understand every detail of an algorithm if you want to use it. And then I say, I think this is bullshit advice. I do not believe you have to understand the nuts and bolts of every algorithm before you use it. It's nice if you do. Don't think for a minute that's the only way to build systems, right? I've been using neural networks for the longest time, and I do have a sense of how gradient descent works. I cannot explain it to you right now. I will have to go and check back and to actually get a better intuition. That doesn't mean that I cannot solve things using neural networks, right? So trying to force people to, well, you're not going to be successful unless you can explain every single detail of how this works. It goes back to our sorting example. I think that's just bullshit advice. I think that's not the way the world works. As an engineer, I've worked on many, many systems, and I've used many, many things that I understand what impact they have. I do not understand the nuts and bolts of how it works. So yeah, that's the final lesson on that thread. Yeah.
The funny thing is, like when I think about all these libraries like scikit-learn, the algorithm they use inside to implement this, for example, logistic regression or something else, are not the same as the algorithms we study in machine learning classes. In machine learning classes, we learn something simpler, right? But then when it comes to exact implementation, this is like a super optimized version, completely different from what we study. So even if we try to, learn and get all these basics of machine learning, at the end, the algorithm that these libraries use is different, right? So it's
absolutely. There's, I think we need a lot more pragmatism in the industry, right? A lot more making impacts, right? Or focusing on delivering value, and a little bit less of purism, or you can't do this unless you know all of these, right? It's sort of like the mentality that
just gatekeeping, right?
Yeah, I get it. I get that you've worked really, really hard getting your degrees and your fancy titles and all of your knowledge, but it's time for everyone, to join as well, even though they don't have those. So yeah.
Yeah, and if you think again about a business where you work, let's say they want to predict something simple like if this user will click on this ad, right? And then if you manage to increase this click-through rate, nobody from the leadership team will care if you know math or not, right? As long as you actually manage to improve this click-through rate or something else, right? So it's more about impact, not
absolutely,
not if you know details or not.
Yeah, and by the way, there are two different paths, and I usually speak to those that want to work in the industry, that want to, have their impact there. There is a path for researchers, and that is completely different. And I do not dare to speak about that because I don't know. I don't have any experience with that. But right there outside in the industry, pragmatism goes a long way for sure. Yeah.
Yeah, we had a comment that feels more like a motivational speech than talking about transitioning. So maybe we should.
There we go. There we go.
It is a good motivational speech, but maybe we can go to the actual, the actual stuff. So one of the things I wanted to ask you, and I'm taking a note to talk about becoming better at coding. But first, let's cover. So we have a couple of things. So let's start with core tools and frameworks that we need to learn to actually transition. So let's say I'm a software engineer. I know how to program. Let's say I know Java, right? I know SQL. I know how to use Git. I know Bash. Maybe I know Docker. All these things. Yeah. And I hear about machine learning. It seems like a cool thing. So what are the core tools and frameworks? So yes, and I watched this video. I get convinced that I don't need to get deep into math. I want to start coding and get my hands dirty. So what are the core tools and frameworks I need to learn to do this?
Yeah, absolutely. Great question. So I think number one, you should start learning a little bit of Python. Since you already know Java, I don't think there's going to be a huge transition for you. It's going to be very simple. Not because Python is the same as Java, but in a week, you're going to get a lot of the differences there, right? You're going to be able to make some progress. So that's number one. Then you get certain core tools that you're going to be using throughout your entire career. And those would be like NumPy for scientific computing. That's a library. And Pandas for data manipulation. And I don't know, Matplotlib and Seaborn and Plotly. Those three, or one of those three, for sharding and displaying graphics. And then you get scikit-learn for a collection of machine learning algorithms. So those are tools that you're going to have to be using. I do not recommend just to go and learn about them just out of the blue, right? Instead, I would recommend you to go to maybe Kaggle or maybe take a course online. And we can talk about specific courses for sure. Take one of those courses that is going to start introducing you to some problems and to some core ideas of machine learning. There is a course in Kaggle, which is an introduction to, I don't remember the name, but if you go to Kaggle, they have tutorials there for free. And one of them is an introductory course that takes you through the Titanic problem in Kaggle, one of the most famous competitions there. And what's good about it is that the only requirement for you is to know Python. They're going to present a problem and tell you how to use decision trees to solve that specific problem. And I think that process is extremely powerful because you go from no machine learning background to understand what the problem is, why you cannot solve it with what you know right now, which is straight software engineering practices, why you need something like a decision tree, how to build it, how to apply it, how to get results. So that line there is exactly what I recommend people to start getting into the industry. First, understand why you will need this, right? Find a problem that you cannot solve by yourself. Understand how you can solve it, and then start getting deeper. Later on, you can get into decision trees and understand all of the nuts and bolts behind the scenes and all of the math and all of the cool stuff. But at the beginning, just learning how to use it is extremely powerful for sure. So yeah, that's what I would do. Yeah.
Mm-hmm. Yeah. So this comes back to one of your tweets, or maybe it was from your course, when you compare two approaches to learning. So one approach is problem-based approach, which you just talked about. So you find a problem, and in this case, it was some problem from Kaggle about this Titanic data set. And you just learn how to solve this problem using this specific tool, decision trees from scikit-learn, right? And then there is another approach, which I think you call top-down approach, where you start from math, then you learn first math, all linear algebra, calculus, whatnot. Then when you know the math, you go to machine learning theory, you learn the theory, and then 4 years later, you finally come to applications, and then, okay, how do I use all these 4 years of math to solve this Titanic problem, right? So here you kind of save yourself this time.
I think, and again, I don't want to get into is this better than this? If you ask me my opinion, I would rather prefer, if I have an electrical outlet here that I need replacing, I don't want to go to college, spend 4 years understanding the math behind electricity and the physics and all of that just to change an outlet. I would rather start with the outlet, find a YouTube video that helps me go through the problem. And if I'm interested, then I can go deeper a little bit and understand why if I touch the positive one, it's gonna just electrocute me or whatever. Bad analogy, but you get the idea, right? I really like the idea of starting with a problem, trying to throw what I know up to that problem and understand why it doesn't work, and then grab the tools that I need to solve that problem and start digging deeper and deeper and deeper from that point on. That's an approach that it worked for me very well, and I've seen work for many, many people as well. So yeah, that's what I usually recommend.
So maybe we can talk a bit about learning resources. So you mentioned Kaggle. So there is an introduction tutorial where you can get and learn how to apply decision trees. At the beginning, before we started this interview today, you mentioned a couple of books as well. So maybe you can talk again about these books and mention some other courses that you would recommend.
Yeah. So if you're a developer, a course that I usually recommend if you want to start quick is the crash course from Google. So Google created this crash course for their own employees, and they published the course online. So it's called Machine Learning Crash Course, and it's free. You don't need to register. You don't need to do anything. You can just start. The only requirement for that course is that you know a little bit of Python. So that's, if you're a developer, that's a great starting point. If you are not a developer, then I do have on my Twitter account my pinned tweet. So if you go to my profile, the tweet that's going to be on the top that says pinned tweet is going to give you a full roadmap starting with an introduction to Python, right? So if you're not even a developer, you can start with Python and work your way to more machine learning, right? So this roadmap is focused on Coursera, which is a platform that I really, really like, right? So you can audit all of the courses for free, or you can pay for the Coursera subscription to get certificates if you want to. But it basically goes from introduction to Python to machine learning, deep learning, TensorFlow, advanced TensorFlow, and machine learning operations. So there are 6 courses there. They're going to take you a few years to go through. So every course is specialization. So it's going to take you several weeks to complete. So we're talking about a roadmap that's going to expand a year for sure. But again, it's just a path. If you want one, that's one. Regarding books, I do like a couple of books specifically related. One of them is deep learning, which is the deep learning with Python. Francois Chalet is the writer, the person who created Keras is the writer of that book. By the way, the second edition of the book is about to be released. I'm really looking forward to that one. The second book is this one here, which is hands-on, machine learning with scikit-learn, Keras, and TensorFlow. This is a book that you can read cover to cover. It's a book that you can start from the beginning. There is a lot of knowledge here. So you pairing this book with a course, it's, you're going to maximize the reward for sure. So that's a great way to start. Yeah.
Okay. Yeah, so I'm just looking at the questions, and the first question is the most voted question is, what are your favorite books? So these two. Do you have? I think you have something else on your desk. Maybe you can also.
I do. So I do have. So those 2 books are the deep learning with Python and the hands-on machine learning are technical books. Non-technical books is the Lord of the Rings, and you cannot see it. It's huge book. I have it. I think it's there. It's huge. This take obviously Lord of the Rings. I have the Spanish version there, and like a self-help book. I'm really into Atomic Habits from James Clear. This book, by the way, I picked it up recently. I realized that I've done a lot of the stuff that's recommended in this book. I've done it, but a lot of it is super, super good. So I really recommend it to anyone for sure. Yeah.
And you have a course about machine learning, and I think this course specifically it focuses on people who are software engineers and who want to transition to machine learning. Exactly the topic today. Maybe you can talk a bit about this course. So what people will find in this course?
So this is a course for people that want to start, but they really don't know how to do it. So I talk a little bit about the right approach that you should take for machine learning. I talk about specific problems depending on where you are, specific problems that you can go and solve. So I give I think it's 10 different problems that you can go and solve. I talk about books. I talk about, job opportunities, stuff like that you want to know. So imagine that you're thinking about getting into machine learning, but you need to talk to somebody. So this is me talking for 100 minutes about the career and what you should expect and how you should approach it and what books and what courses you should take to make it into the industry. I'm actually working right now on version 2 of the course, which, I'm just going to replace the first one because since I built that course, I've learned so much. So I'm working on the second version to replace the first one, just to make that advice a little bit, let's call it better, right? So yeah, that's what it's about. Yeah.
But yeah, I remember watching this course, and to me, what I felt after watching it is that you somehow got into my head, took all the thoughts I have about how engineers should approach getting into machine learning, and you put it out in such a concise and motivating manner. So this is excellent. I recommend everyone who is interested in this to check this course out.
Yeah, I appreciate it.
We have quite a lot of questions, and one thing we promised to get back to is for those who are not necessarily great at coding, how can they improve this? Because one of the things you mentioned is that coding is very important, and many people who failed machine learning course, it was not because of the lack of math skills they had, but because of their coding skills. So how can people improve their coding skills?
Yeah, so that is a great question. So there is definitely a path for you if you don't know coding to get good at machine learning itself and then pick up coding as you go. There is definitely a path there. I do have less experience with that path because I'm usually focused on people that already know how to code. So it's obviously natural for me to recommend people, if you don't know how to code, first get excited about building solutions. First, get there. So don't worry about machine learning. That will come at the right time and right place. Focused on building things with your computer, right? Focused on building programs, learn Python, learn how to solve different problems. And machine learning will be a nice addition to that. By the way, this is just what I recommend. It's not necessary to, I know people that started with machine learning and added coding later on. There is definitely a way to make it, but I usually recommend people to start with Python, focus there, and then come back into machine learning. Yeah.
Mm-hmm. Yeah, my wife is doing a course now. I don't remember the name. It's about Python. And what she's doing there is she uses Selenium to automate job application process on LinkedIn. So in LinkedIn, there is this quick apply button, right? So you can apply from LinkedIn without filling in like a big application form. So she wrote a bot that goes through LinkedIn every day, finds all these easy apply buttons and clicks on them. This is a cool project. It has no machine learning in it at all, but this is a fun thing to build.
Yeah,
and
definitely.
You can do so many things with this with tools like Selenium. You can automate so many different routine things. So like if you're looking to improve your coding skills, maybe this could be a fun thing to do, like write a job application bot.
So many projects that you can build that don't require machine learning. Actually, the first rule of machine learning is you may not need machine learning at all to solve your problem, right? That's the first rule. So yeah, there is so much to do without it. Yeah, for sure.
And what about like we need some not just coding, we also need to follow some good practices, like good software engineering skills. Like how can we improve this kind of skills for model deployment, for production?
I know what you're focusing on right now. So I was going to say, before you mentioned model deployment, I was going to say that an area that's so valued of being an engineer is getting experience on algorithms and data science. And data structures in general. So that the computing fundamentals part, it's very underappreciated, I'm going to say, but it's extremely helpful in your career. Remember, you're not just limited to do one thing here. The only thing that I'm going to do is building models. There is way more to building models or to providing solutions than building a model. And that comes to the second part, which is what you just mentioned. Machine learning system, the life cycle goes from project scoping, where you have to take a project and understand it and decide what is the best solution, decide whether there is even machine learning here to be applied. So it goes from there. Communication is key there. Goes to the data part of the life cycle, where you grab the data, collect the data, store the data, transform the data, do all of that. Goes to modeling, which is usually where we focused when we talked about machine learning, is the sexy part, right? Building this model that predicts things. And then goes to deployment, maintenance, and monitoring. Requires a lot of what we call machine learning operations, or, how do we deploy this thing? And then containerization comes into play, monitoring those APIs and the cloud. So if you look at the whole life cycle, you're going to realize that an engineer has to do a bunch of different stuff. Now, I know people that specialize in one of those buckets. They specialize in the data. They're, data analysts, for example. People that specialize in the deployment, maintenance, etc., which is the more like an MLOps, and people that specialize in modeling part, right? But some people have to go through the whole spectrum. Some people have to work on every single step of that life cycle. So definitely a lot of opportunities, definitely a lot of skills to acquire. So yeah, anything that you can do to become a better engineer, anything that it's just going to help you providing value at the end of the day, which is what matters. Yeah.
Do you have any specific recommendations how to approach that? So like I see two things. So in the process you mentioned, So first you said we formulate the business problem, then there is the part when we do data preprocessing, then there is the sexy part of modeling, then there is deployment part. So 2 out of these 5 steps, so the data prep and model deployment, they are very heavy on engineering, right?
They are.
Do you have any specific recommendations how to become better in these particular phases, like when it comes to
Absolutely.
engineering?
So in the model, in the deployment part, it's gonna, any skills that you can grab from DevOps, they're gonna pay a lot of dividends for you, right? Like learning how to build APIs just using Flask or Fast API in Python. So all of that knowledge they're gonna be acquiring before even getting into machine learning, they're definitely gonna pay off. Learning how to use Docker, something like Docker, how to put your application, your API inside a container is definitely going to pay off, right? Learning a cloud provider or how to use Amazon, how to use Google Cloud, or in the case of Amazon, AWS or Azure, those cloud providers, learning how to create Lambda functions, all of that stuff is definitely going to pay off here, because it's about building systems that clients have access to. So all of those little things that you're putting together today in preparation to learn machine learning or to become a better engineer are definitely going to pay out when you get to the end of the road, or not the end of the road, but whenever you get to the market and you start trying to deliver this value. So yeah, don't waste any opportunities, or don't say no to any opportunities to become a better engineer, because all of that factors and all of that is going to help. Yeah.
Yeah, thanks. Maybe I just want to add a bit that the things we discussed when how to approach learning machine learning also apply here. So you don't just go and read a book about the cloud. You think first about the problem, and then you try to solve this problem with the cloud, right? So you focus on problem first, because otherwise the cloud is such a big topic.
It's just a
Then
huge thing. Yeah.
Yeah, it's not possible to and then okay, how do you?
Yeah.
Like,
There's not such thing as go and learn the cloud.
Yeah, exactly.
Here are 5 steps to learn the cloud. There is no such thing. It's just huge, right? So you just have to just pick and choose. And what do I need right now in order to get this project here in the next state, right? So what do I need to learn? Oh, it's a Lambda function. Oh, I need to put that Lambda function behind these things. So that's the way you start building all of the puzzle pieces that are going to get you to a final solution. Yeah.
Yeah, we have a question, and I'm interested about your take. If what is in your opinion the difference between machine learning and data science?
Well, that is a hard question to answer, because I don't think there is consensus on the industry. I do see personally, and this is just my personal opinion, I do see machine learning as a more hands-on practical side of the equation, and I see data science as a more theoretical field. That is just me. A lot of people will definitely disagree. A lot of companies use these titles interchangeably. So like, you're a data scientist and what you're doing is very hands-on, and you're a machine learning person and what you do is very theoretical. But I do sort of like separate those two in my head like that way. That machine learning is more hands-on, more let's build something, let's put it out there. Data science is more science, right? It's more theory. It's more let's create things that don't exist right now. So that's the way I look at it. Yeah.
Interesting. So the way I look at this is a bit different. So it's from a different angle. So the way I think about this, so you have data science, and machine learning is one of the tools there, but there are other tools. So like, for example, if you are solving a problem with data science, you don't always need to go and take machine learning and use it as a tool. Maybe there is a simpler approach that you can use. Maybe you can just use counting.
I like that one. Yeah. I definitely like that way. So you look at machine learning as a subset of data science.
Maybe not a subset. It's like, you are a carpenter and you have different tools, right? So one thing you have, I don't know what kind of tools carpenters have, I don't know, hammers.
A hammer,
And yeah,
a saw.
and then maybe a tool set with like different hammers. This would be machine learning, right? And then
Okay,
there
I
is a
see.
different set of tools that would be maybe something else.
I like it. I like it.
Yeah, but
So a data scientist to you will be somebody that's capable of using machine learning, but is also capable of doing other stuff.
Yeah.
Or using other different tool sets than not only machine learning. Yeah,
But
I like that.
I haven't seen other people actively saying this, so I'm not sure like if there is consensus. But this is how I like to
be
think
honest.
about this.
I've seen these concepts used all over the place for two different things. Yeah, so I'm not sure there is consensus.
Okay, so we have a question from Ali. I am an application developer manager. So there is a lot of abbreviations, so I'm trying to read it. So I'm trying to learn machine learning. Should I start with machine learning projects or attend course or learn math, and how to decide which area in machine learning I can excel? I think we covered that, but maybe we can reiterate a bit. So what do you think?
Yeah, so what I would say is if you already got coding skills, if you already know how to develop software, there are two ways for you to start. One way is try to find a problem really quick and try to solve it. And the Kaggle tutorial is the perfect place to start. And you're not gonna miss it. Go to Kaggle and there's gonna be a list of tutorials. You will know which one to pick. If you want a little bit more theory before starting with a problem, I would recommend you go on to the machine learning course in Coursera from Andrew Ng. It's an amazing introduction to machine learning. I think like 4 million people have taken that course so far. It's probably one of the most popular one, if not the most popular course out there. Start there, that's gonna give you a ton of theory. And from there, you can start jumping back and forth from problems. So those paths, any of those will definitely work for you. Yeah, that's what I would do.
That's a good course, and I am one of these 4 millions.
Oh yeah, for sure, me too. Yeah.
Yes, this is how I started my career in machine learning, by watching that course. Now we have a lot of comments. So I wasn't able to keep up with them. One of the comments I noticed about this lizard book is that a few people commented that math gets quite difficult in chapter 4. So how did you deal with this?
So let me check chapter 4 here really quick. Let me see what we're talking about. The lizard book, part 2, chapter 4, training models. Is that the one? Or part 4? Well, there is 4 in the book. So in training models, so I'm not sure. So let me tell you this. I'm not a math guy. I promise you that, right? I'm as good as math as anyone else that is not good as math. And I've been able to survive and I've been able to provide value. So I want you to put aside that math is going to kill me. And I want you to focus on what can I do today to provide value. And I promise math is going to come with it without you thinking that you have to go through the math. So I cannot comment on chapter 4 because honestly, I haven't.
Maybe that's a different. There are a couple of lizard books out there.
Maybe there is a different lizard book. So this is the one that I have here. Maybe there is a different one. Chapter 4 here is about training models. Maybe in that chapter is when he talks about gradient descent. Get the idea, get the overall idea. You do not have to understand how to do gradient descent by hand. That's why we have libraries that do that for us, and we don't have to implement training loops anymore by hand. That's not necessary. You don't have to sort of like tattoo that into your brain in order to do machine learning. So yeah, I think that's the best recommendation I can give regarding math.
Yeah. So what worked for me, I remember that when I saw these big formulas, usually it's some linear algebra, some multiplications. And for me, what helped is trying to translate these formulas into code. And when I see them in the code, I understand, okay, this carry thing is just a bunch of for loops. And I know how to deal with for loops because I am a developer, right? So I know how to write this, even though it's like a nested, for matrix multiplication, I think you need 3 loops. But at the end, it's still a bunch of for loops. And we as developers, we know how to deal with for loops. So then like decomposing and expressing things in code really helps.
Yeah, that's
and
cool.
then it's not scary anymore.
Yeah, no, what I try to do is I try to get past the formula by trying to explain. So what is an intuitive way to think about what's happening here, right? Instead of like worrying about the formula and how it's done, how can I explain what's happening? And that helps me a lot to get past that formula, right? Not necessarily to understand how to do it by hand, but definitely to understand what's happening and why it works. So yeah, that's what I try to do.
Yeah, thanks. So there is a question about your course and the link to this course. I will post this link a bit later. When we finish, I will post this in the description. I will also post your Twitter, Santiago. Anything else I should add in the description?
I think join me on Twitter for sure. So stay tuned. That's what I'm doing, and I really feel happy that I feel validated that a lot of people find the content helpful. And by the way, by following me, you're also helping me because if you provide feedback, if you tell me what makes sense and what doesn't make sense, that's the way I learn as well. So yeah, that's the only thing that I'll say. Yeah.
Okay. Any last words you want to say before we wrap up?
Thank you for having me here. I'm really, really excited about the talks for the next few days, especially the one from Elena. I'm looking forward to that one.
Yeah, so Elena already, like her video here is the most watched video on our channel about why your machine learning projects fail. So that one, her second talk, I think will overcome the first one. I'm sure.
Okay.
Yeah. Like I'm really looking forward to that one as well.
Yeah, for sure.
Yeah, thanks a lot for joining us today, for sharing your knowledge with us, for giving, I think it was very motivating because I know how many developers feel about math. And I hope if we changed the mind of some people who will now go and start solving problems, that would be really great.
That's the goal, man.
Yes,
that's the goal.
And I think you managed to do this. So I'm pretty sure that a few people today, after finishing this talk, will go and instead of focusing on math, will go on Kaggle, will find this tutorial, and they will fit a decision tree, and they will stop being afraid.
Yeah. Definitely. Thank you.
Thank you, Santiago. And thanks everyone for watching us. And please check, if you don't know about the conference, there is a link about the conference. Check the talks we have and you can register and you will get a notification about the talks. So that's all for today, and see you tomorrow.
Bye.
Bye-bye.